This is a training module on the Telegesis ETRX2-PA ZigBee Mesh Networking Module. Welcome to this training module on ZigBee ETRX2-PA Wireless Mesh Networking Interface. This module will provide information on the ZigBee radio specification, hardware, and firmware interface and applications that fit this module. There are a multitude of standards that address mid to high data rates for voice, PC, LANs, video, etc. However, sensors and control devices don't need high bandwidth, but they do need low latency and very low energy consumption for long battery lives and for large device arrays. ZigBee is poised to become the global control sensor network standard. It has been designed to provide low power consumption, simplify implementation, high density of nodes per network, reliable data transfer, and appropriate levels of security. Several topologies are supported by ZigBee, including star and mesh. Star topology is most useful when several end devices are located close together so that they can communicate with a single router node. Telegesis ZigBee module uses mesh networking to allow for redundancy in node links so that if one node goes down, a device can find an alternate path to communicate with another. The Telegesis ETRX2-PA module has been designed to be integrated into any device without the need for RF experience and expertise. The form factor of the ETRX2PA is identical to the ETRX2, so either module can be used depending on the range requirements of the particular application. Utilizing the Ember ZNet meshing and self-healing stack, the ETRX2PA enables you to add powerful wireless networking capability to your products and quickly bring them to market. With single-ended RF output, the module is available with integrated antenna or 50-ohm UFL coaxial connector or 50-ohm pad terminal on the bottom of the module. The configurable functionality often allows the ETRX2-PA wireless meshing module to be used without an additional host microcontroller. The Telegesis ETRX2-PA module is a power-amplified 2.4 GHz ISM band transceiver based on the Ember EM250 single-chip ZigBee/IEEE 802.15.4 solution. It consumes typically 17 dBm, 50 milliwatts of output power with high sensitivity of up to -97 dBm at 1% packet error rate and a hardware acceleration for IEEE 802.15.4 compliant transmissions. The data transfer rate is compliant with IEEE 802.15.4 specifications at 250 kilobits per second. The ZigBee module can be used almost in every area of communication like home building automation, wireless sensor network, PC peripherals, metering application, wireless alarm, and security systems. The main building blocks of the ETRX2PA are the single-chip EM250 from Ember, a 24 MHz reference crystal, and an RF front-end circuitry optimized for best RF performance. The ETRX2PA module allows extended range of operation by means of an integrated high-efficiency power amplifier inserted in the TX path. With single-ended RF output, the module is available with integrated antenna or 50-ohm UFL coaxial connectors or 50-ohm pad terminal on the bottom of the module. A low-loss LTCC bandpass filter for the 2.4 GHz ISM band is added to both the TX and RX path to attain immunity against interference. The EM250 contains an internal low dropout regulator. The module can be supplied with an additional integrated onboard LDO regulator or DC-to-DC converter. Some applications can benefit from this additional regulator in instances where further extension of the input voltage range is required. Extended battery life is obtained by replacing the regulator within the EM250 with a special ultra-low quiescent current regulator. Two different types of regulators are available: a linear low dropout type or a high-efficiency switched buck regulator. A second option which is available is an onboard 32.768 kHz crystal reference. This option can be provided for applications which require a high-precision reference clock. The ETRX2 module has up to 4 analog inputs. Readings with reference to the internal 1.2 volt reference voltage can be made locally as well as over the air. I/O pins 0 through 11 are bidirectional I/O ports which can be controlled locally as well as remotely by accessing local as well as remote S registers. The functionality of the I/Os can be controlled using 3 single 16-bit registers representing the data direction. The AT-style command interpreter can be accessed via the TXD and RXD pins. The ETRX2-PA can buffer up to 128 bytes of incoming data in a software first-in, first-out buffer and uses X-on/X-off or hardware flow control. Up to 4 I/Os can trigger user-definable actions. User configurable edges can cause interrupts if this function is enabled in the S registers. Pulling the reset pin low will cause the module to restart. I/O number 3 can alternatively act as a special function pin which can generate output waveforms up to 12 MHz or act as a pulse width modulation. The modules have been preloaded with a standalone bootloader which supports over-the-air bootloading as well as serial bootloading of new firmware. In order to enter the standalone bootloader using a hardware trigger, pull a D2 GPIO5 to ground and power cycle the module. The ETRX2 firmware uses the meshing and self-healing Ember ZNet Pro Stack to overcome many of the limitations of the tree network topology of the ZigBee 2006 stack. TE Meshing Stack implements routers and coordinators as well as end devices. When the module acts as a router, it is typically a mains-powered device, whilst a sleepy end device can be battery-powered. The module is also able to act as a PAN coordinator through external host control. The Telegesis firmware also allows low-level access to physical parameters such as channel and power level. Using the default firmware of the ETRX2-PA is controlled using a simple AT-style command interface and mostly non-volatile S registers. The AT command dictionary document will introduce full lists of all the available AT commands. If you need to find out which firmware resides on your module, simply type ATI followed by carriage return and you will be prompted with the module's manufacturing information. The firmware is able to upgrade either via serial link or over the air. At power-up, the last configuration is loaded from non-volatile S registers, which can eliminate the need for an additional host controller. The diagrams above show the typical output power and module current is dependent on module supply voltage and EM250 power settings in the normal mode. The power setting is the setting of the EM250's output power before amplification. This setting is used by all firmware running on the ETRX2-PA module.